2,400 years ago, a Persian family slept against thick adobe walls that absorbed daytime heat and radiated it through freezing nights. Last Tuesday, a homeless man in Detroit slept against a parking garage wall that did the exact same thing. The Persians cooled buildings by 40 degrees using towers that funneled wind over underground water. A car sleeper in Phoenix hangs a wet bandana in his window with a fan behind it and drops the temperature 20 degrees. Identical physics, but the average American home uses none of this and pays $2,000 a year for that choice. The foundation of the entire Persian system was the walls themselves. Persian buildings used adobe, rammed earth, and stone walls 2 to 3 feet thick. These materials have high thermal mass, meaning they absorb enormous amounts of heat energy during the day and release it slowly overnight. In summer, the thick walls soaked up desert sun all day while keeping the interior cool. By the time the stored heat finally radiated inward, it was nighttime, and the air outside had cooled to 50 degrees. So the walls started absorbing coolness instead. The cycle repeated daily. Exterior temperature swung 70 degrees from day to night. Interior temperature barely moved 10 degrees. In winter, the same walls captured daytime solar heat and radiated it slowly through cold nights. Free heating, free cooling, same wall. The modern homeless parallel is hiding in plain sight. Concrete has a heat capacity of roughly 2 megajoules per cubic meter per degree Celsius, even higher than Persian adobe. Parking garages, bridge underpasses, subway station walls, and building foundations all function as thermal mass structures. Underground parking garages stay 20 to 30 degrees warmer than surface temperatures in winter because the concrete stores heat from vehicles and building systems and releases it through the night. Homeless people sleeping against concrete walls and underground structures benefit from exactly the same thermal mass buffering that Persian homes used. The material changed from mud brick to reinforced concrete. The physics are identical. Standard American wood frame homes with drywall have almost zero thermal mass. Turn the furnace off and the temperature drops within an hour. Persians would have found that baffling. However, thermal mass only handles half the problem. The other half is moving air, and the Persians solved that with the most visually striking invention in this entire system. The bādgir, which literally means windcatcher in Farsi, is a tower rising from the roof of a building. It catches prevailing wind at height and funnels it downward into the interior. As the air descends through the tower, it passes over underground water channels called qanats, and the moisture evaporates into the moving air. Water absorbs 2,260 joules of energy per gram when it evaporates. That energy comes directly from the surrounding air. Temperature drops 20 to 40 degrees by the time the air reaches the living space below. The city of Yazd in Iran, a UNESCO World Heritage Site, contains thousands of bādgirs, some over 1,000 years old. They are still standing. They still work. No moving parts, no electricity, just a tower, some water, and thermodynamics. The modern homeless parallel is the wet bandana in a car window. Soak fabric in water, hang it where airflow hits it, and evaporative cooling drops the temperature in the immediate area by 10 to 20 degrees. Car sleepers in Phoenix and Las Vegas use this because it is the only cooling system that runs on zero electricity. Add a battery-powered clip fan behind the wet fabric and you have built a micro bādgir in a sedan. Same physics. 24 centuries later, central air conditioning uses roughly 3,500 watts to achieve what the Persians did with a tower and some water. An evaporative cooler uses 75% less energy than air conditioning, but the average American home does not have one because cheap electricity made the Persian method feel unnecessary. Now here's the section that made me want to make this video. The yakhchāl, literally ice pit in Farsi. This is the dome from the opening of the video, and the engineering behind it borders on absurd. The walls were made of a mortar called sarouge, a mixture of sand, clay, egg whites, lime, goat hair, and ash. The walls were up to 6 feet thick, an estimated R value of 30 to 40, which is comparable to a heavily insulated modern freezer wall. The dome shape created a passive convection cycle as warm air rose to the top and vented out, pulling cooler air in at the base. Some yakhchāls connected to qanat water systems for additional evaporative cooling underground. Workers froze water in shallow channels during cold desert nights when temperatures can drop to 30 or 40 degrees even in arid regions. They shaved the ice at dawn and stored it in the underground chamber. The result was frozen food and ice preserved through an entire summer in a place where daytime temperatures hit 120 degrees. Persians were eating falude, one of the oldest frozen desserts on Earth, roughly 2,400 years ago. The modern homeless parallel is the buried cooler. Encampments in arid western states dig a shallow pit, place a styrofoam cooler inside, and cover it with dirt and cardboard. The earth below the frost line maintains a steady temperature of roughly 55 degrees year-round, regardless of surface conditions. A buried cooler stays 20 to 30 degrees below ambient air temperature in summer without any ice. It is the same underground thermal stability the yakhchāl exploited. Different materials, identical principle. If you're finding this useful, hit subscribe. I cover street survival science and ancient engineering every week. The Persians did not stop at cooling. They also solved water delivery across entire desert regions using one of the most impressive pieces of ancient infrastructure ever built, the qanat. Qanats are gently sloping underground tunnels that carry water from mountain aquifers to desert cities using gravity alone without pumps or electricity. The oldest known qanat at Gonabad, Iran, has been in continuous operation for approximately 2,700 years and still supplies 36,000 people today. Beyond water delivery, qanats provided passive cooling. Air blowing across underground water lost heat through evaporation, and this cooled air was channeled into living spaces. The qanat was simultaneously a water supply and an air conditioning system. Homeless people in modern cities tap into a parallel infrastructure without knowing it. Public fountains, park splash pads, fire hydrant drips, and fast food restaurant bathrooms all function as distributed public water access points, modern qanat endpoints built into urban infrastructure. In hot cities, homeless people position themselves near misters, fountains, and splash pad runoff for evaporative cooling. Moving water creates cooler air around it. The qanat principle is alive in every city park. Then there is the earth itself. Below the frost line, the ground holds a steady 55 degrees year-round. Persians built semi-underground rooms called shabestan specifically for summer sleeping. Several feet below grade, surrounded by earth, these rooms maintained 65 to 75 degrees when the surface baked above 100. New York City's subway stations maintain roughly 70 to 80 degrees year-round, regardless of surface weather. In winter, that is 30 to 50 degrees warmer than the street above. Homeless people in every city with underground transit use earth-coupled spaces instinctively. The temperature difference is obvious the moment you walk down the stairs. The shabestan principle is rebuilt in concrete and tile. Earth-sheltered homes were a growing movement in America during the 1970s energy crisis. Homes built partially underground used 50 to 80% less energy. When energy got cheap again, the concept was abandoned. The Persians never had that luxury. The Persians also oriented every building to the sun's seasonal path. Main living spaces faced south to capture maximum winter sunlight. Roof overhangs shaded those same windows in summer when the sun was high overhead. Free heating in winter, free shading in summer, from the same wall. Experienced car sleepers do the same thing. Park facing south in winter so the windshield acts as a solar collector, heating the cabin 10 to 15 degrees on a sunny day. Face east in summer so the windshield catches only weak morning sun. Tent placement in encampments follows identical logic, openings aimed south in winter for warming, north in summer for shade. Roughly 70% of American homes are not oriented for passive solar gain. The front door faces the road regardless of compass direction. 2,400 years of proven solar engineering ignored for driveway convenience. And finally, the Persians understood something about communal design that modern suburbia deliberately abandoned. Persian homes were built around shared courtyards where cooking fires, body heat, and resources accumulated in a wind-protected microclimate. Caravanserais were roadside inns along trade routes, and they provided free overnight shelter to any traveler. Thick walled rooms surrounded a central courtyard with shared fire and water. Over 1,000 were built across the empire. Modern homeless encampments mirror this layout almost exactly. Tents and shelters cluster around shared fire pits, communal cooking, mutual aid distribution, and night watch rotations. The physical architecture of survival has not changed because the physics of shared warmth has not changed. Two people together produce between 160 and 200 watts versus between 80 and 100 watts for one person alone. So what have we actually seen? A civilization from 400 BC that solved heating, cooling, water, food preservation, ventilation, and communal shelter across the harshest climate extremes on Earth. Zero electricity, zero fossil fuels, and modern homeless people who arrived at the same solutions independently because the laws of thermodynamics do not expire. The average American home pays $2,000 a year to power machines that do what physics already does for free. 2,400 years ago, a civilization built ice factories in the desert and cooled buildings with towers and water. Today, the people with the least are the ones who remembered what the rest of us forgot. If this changed how you think about survival and engineering, subscribe.